Hi there everybody, in this video today we're going to be looking at the ideas behind sampling. Now sampling, as you can see from this little blurb down here, is the mathematics behind getting the correct kind of sample, because what we do in statistics is we get some information, we analyse the information, we draw graphs. That analysis and those graphs don't mean anything if we haven't collected the data correctly. So in this video we're going to be going into the ideas behind collecting data and the correct way to do that, and you're going to hear some words that are associated with sampling that you need to know about. But the broad context here is we've got to collect data the right way, or the analysis of the data is meaningless. So here's what the syllabus says. Examine the concept of a random sample. Discuss sources of bias. So here's some words that are really important. Random sample, what a random sample is, what bias is, and procedures to ensure randomness. Use graphical displays of simulated data to investigate the variability of random samples from various types of distributions, including uniform, normal, and Bernoulli. I'm going to deal with that later. In this video here, we're just going to talk about the first two bullet points. It's important to understand that you've got a whole population that we're trying to choose from here. And our samples, here we've got 6 different samples here, they can overlap. There might be, so if you can imagine the population is the population of Australia, and we're trying to choose a sample of 1,000 people to talk to ask their opinions about how they're going to vote. There might be overlaps between them, they might be completely different, they come from different places, different times. So there is always going to be variability from the samples that we take. But the first idea here is the idea of population and sample and what they mean. So here's some words that you should know. A unit is a single member of the population. The population is all possible people that you want to look at. Now I know that sounds like a simple thing, but you need to understand that if we're looking for the musical opinions of 16-year-olds at high school, the population we're looking at is all 16-year-olds at high school. That's the population that we're going to be sampling from. A census measures the characteristics from everybody in the population. A sample is a subset of the entire population. So if you look at that blue circle there, that would represent a census if we did everybody. The pink circles within that are samples. 2 words here that are important to know. Parameter is a measure that describes something about the whole population. So often we talk about the mean of a set of data, and I'd use this letter here, the Greek letter mu, the standard deviation, the variance. There's some of the symbols that we use to measure those. A statistic, on the other hand, is a numerical measure that describes something or the characteristic for a sample. So we might talk about the mean of a sample, and that's the way we write it in statistics, x bar, or the standard deviation of the sample, or the variance of the sample. So you can see we have a slightly different notation for sample means, standard deviations and variance, versus population mean, standard deviation and variance. I think it's pretty obvious most of the time why we'd want to do a sample rather than a census. A census is very, very expensive to start off with. We're looking at the entire population. Now our population we're looking at might be very small and limited, but still sometimes taking a census takes a long time. So doing a sample, as long as it's random and it represents the population, is a much quicker and easier and more cost-effective way to get information about the entire population. Sometimes it just doesn't make sense to do a census either. If we want to look at the average weights of fish in a lake, it'd be impossible to catch every fish. So instead we take a sample of the fish. So let's quickly talk about bias. Bias happens when some members of the population are favoured over others in terms of people that are getting into our sample. So bias can come in so many different ways, from personal bias to the method that you're using. There's all kinds of ways that bias in surveys come about. There's 2 main types, systematic bias and sampling bias. Okay, here's systematic bias and sampling bias. We'll talk about a few of the different elements of those. So systematic bias occurs, as it says here, from decisions made in the preparation process. So we really need to consider a lot of things to do the sample properly without any bias, so that every member of the population has an equal chance of being in the survey. So there's a lot of information on this page here about this kind of systematic bias that you could get. Sampling bias happens when we have things like we don't cover everybody in the population. Some people don't respond to the survey, and when our responses aren't truthful, that happens as well. So these things happen all the time. Eliminating bias from surveys is nigh on impossible, but you can minimise it and talk about it and understand it. So here's a few questions that you could answer here, and we're trying to see, is this fair? Where's the bias going on? So first one, an interviewer outside a supermarket on Saturday morning asked people going in, do you prefer Razzle dishwasher detergent or an inferior brand? All right, what's the sources of bias there? Okay, so first of all, we'd have to look at what's the population here. I guess it's people who buy dishwashing detergent, or people who use dishwashing detergent. So that's a huge sample. Outside a supermarket, just on a Saturday morning, you've got a limited number of people who could even be in the survey here. So there's heaps of people that are excluded from this survey. And the question is very leading, talking about an inferior brand. This is a bad question, heaps of bias, and the way it's set up, not good. 2,000 mobile phone numbers were telephoned at random and people answering were asked, what kind of dishwasher detergent do you use? Okay, so first of all, the thing that comes to mind here is the mobile phones. The concentration of mobile phones would probably be more dense in people of certain ages. People over the age of 80 was unlikely to either answer the phone or have a mobile phone, so they will be excluded from this survey. So that's something to think of here. Yeah, and that's, as it's got here, some people would just hang up. In this survey, people would just ignore you as well. And the last situation here, 200 people are chosen at random from the electoral roll of a litmus test electorate and interviewed at home on a Sunday morning. They are asked, if an election were held tomorrow, who would you vote for? Anyone who wasn't home was contacted later at a follow-up that evening. Altogether, 190 people were successfully contacted, and 10 refused to answer. They were put in the don't know category. This is pretty good, actually. This is a pretty good way of doing this survey. It's pretty solid. The only problem here is that just because of the way that people have voted in the past doesn't mean they're going to vote that way in the future. So, but it is a pretty good way to do this survey. Okay, let's get into some methods of doing samples now that are random sampling methods. So the easiest one to talk about is simple random sampling, where each member of the population has an equal chance of being selected. This is the most easiest method, but it's hard to do sometimes. We're going to talk about some methods of doing it. Another method you could use is called stratified random sampling. Okay, so that is if we divide our population into strata. So typically, if you've got a school, you've got 7, 8, 9, 10, 11, 12, and then you choose people from each of the different strata. So you take a simple random sample from each of those groups. That is a really good way of doing things, so that you get representation in the sample in the same proportions of the population. So if you've got twice as many Year 7s as Year 12s, you would select twice as many Year 7s as Year 12s in your survey. Cluster sampling is a method where we divide the population into clusters, groups, and then we sample each different cluster. So for political surveys, each city in Australia might be considered as a cluster. They do a random sample of different clusters and then sample from within those. So that's what we call cluster sampling. Systematic sampling is when we choose every 5th or 10th person on a list. So in simple random sampling, we could just get a list and randomly choose 5 people. In systematic sampling, we're choosing every 5th person on a list. Okay, let's look at this situation. A distributor has 34 office staff, 23 store employees, and 43 delivery drivers. How many of each should he be selecting to make a stratified random sample of 10? Okay, so we'd find the proportion of each of his total population. So he's got 100 people that he's employing. 34 of them are office staff, 23 and 43 are delivery drivers, okay? So we can work out that in his sample, 34% of his sample should be office staff. So 34% of 10 is about 3.4. So you could say around about 3 people should be office staff. Same thing for the store staff, 23%, which is around about 2, and delivery staff, 43%, or around about 4. So 4, 3, and 2 would be the most balanced way to get the sample numbers in this case. I want to talk about a really common method of doing sampling here. It's called the Recapture technique. So we use this all the time to estimate populations of animals in a certain area. We do it with sharks, we do it with all kinds of animals. So the way that we do it is we catch a certain number of, in this case it's frogs, and we've tagged 40 of them and release them back into the area. Then we go back a number of days later, once the frogs have time to mix in the population, we catch 50 frogs and find that of those 54 were tagged. So using proportions, we can then give an estimate of what the total population is. So here's the calculation. We're saying that those 40 frogs, the proportion is 40 out of the total number. So we tagged 40 out of the total number of frogs in the area. Once we'd captured 50, 4 out of the 50 were tagged. So we can just equate those two there. But 4 out of 50 is the same as 40 out of our total number of frogs in the area. So solving that equation will give you an idea of how many frogs. That's called the Recapture technique. Simple random sampling, easy to do. So if we've got 618 students and we want to choose 40 to take part in a survey on homework, what we need is to make a list of everybody from 1 down to 618, write each number on a piece of paper, and we want to draw 40 out at random. Now that might sound really boring, but it will get the job done. On our calculators, we can generate random numbers really easy. Rand with the brackets gives us a decimal number between 0 and 1, and we could use, for example, the first 3 digits there and use that for the people that we're going to pick in the sample. So person number 547, then person number 129, etc. We can put those numbers in a table. It's really easy to generate integers. So rand 1, 6 will give you an integer between 1 to 6. So this would simulate, rolling a dice. We've got a 4 and we've got a 3 there. Or it will give you a list. So if you go rand list 4, there's a list of 4 numbers between 0 and 1, decimals, or rand list 416 is a list of 4 numbers between 1 and 6, and it's only going to be whole numbers, integers in this case here. So, we can generate lists of random numbers really easy on our calculator. If we want to do a bigger sample, so we've got a population of 921 students, we want to choose 200 out, this is how we do it on our calculator. So, random list, we want to generate 200 numbers, 1, 921, will give us a big long list.